Good morning. I would like to make a presentation. Passenger rover model in Matlab-SimMechanics environment. To begin with, I would like to present briefly the plan of presentation. Introduction, modeling the basic driving elements of the rover, including the rover differential, the rover wheel, automatic operating mode of the rover operation simulation, summary. The object of this works was to develop a 3D model of a passenger rover in the Matlab-SimMechanics environment and validate its performance by running simulations. The rover was designed and built by members of the Koszalin University of Technology scientific group named Without Resistance at the Faculty of Technology and Education. It is a hybrid of a Mars rover and a go-kart. The innovation of this project is a modified suspension of the rocker bogie type, which allows you to adjust the clearance of the vehicle depending on the mode using electric actuators. Thanks to this solution, the rover can be controlled remotely in autonomous mode, or its suspension can be lowered, thus turning it into a passenger vehicle. Simulations conducted on the model are to determine what capabilities the built vehicle has. The proven chassis design of the already built robot inspired the process of building the simulation model of the passenger rover. It started with making the model in a MATLAB environment using the SimMechanics library based on the actual model. The mass of each component, dimensions, and moment of inertia was extracted from the 3D model built in the SolidWorks environment. First, the internal housing of the mechanism that allows the rover to stabilize itself when overcoming bumps was created from the components P1, P2, P3, and P4 connected by weld blocks, which symbolizes stationary connection. The mechanism itself is located in subassemblies Z1, Z2, and Z3. These are 3 gears mounted on 35 mm long shafts, connected by gear constraint blocks used to define the relationship between the wheels. Finally, elements P5, P6, P7, and P8 were used to make the outer casing to which the battery holders will be attached. The final component completed was a modified rocker bogie suspension which included the legs, cylinders used to adjust ground clearance, wheel mounts, and the wheels themselves. The body blocks representing the wheel and tire are connected to the ground block using a custom joint, which allows for a custom combination of prismatic, rotational, and spherical joints to accommodate all of the wheel's degrees of freedom relative to the ground. On the other hand, the revolute connection allows the wheel to rotate relative to the mount. The passenger rover has 2 modes of operation, the autonomous mode and the passenger mode. In autonomous mode, the actuators that change the wheelbase are shortened to the maximum, resulting in a shorter leg span and a taller overall vehicle. The length of the actuators and the positioning of the legs were modified in the simulation model, resulting in a model that reflects the rover in the second mode of operation. Simulations of the model behavior will be carried out as follows. The rover will be placed on 6 platforms, each under 1 wheel. Then, the platforms will be given an appropriate forcing in the form of a displacement signal along the y-axis, representing a given obstacle or terrain change. To make the simulation as close as possible to the actual passage, during the simulation, the rover speed of 2 km/h was assumed so that the second and third pair of wheels would receive the excitation with an appropriate delay, simulating the passage of the rover over the obstacle. The process of acceleration and deceleration of the rover and the resulting dynamics are not included in the model. In the simulation, the forcing signal given to the platforms will simulate an obstacle with a height of 10 centimeters and an angle of overrun of 45 degrees on which the rover will enter and then exit. The change in the y-axis position of the first pair of wheels is shown in Figure A, of the second pair in Figure B, and of the third pair in Figure C. The y-axis position of the chassis is shown in Figure D. The highlighted points in the graphs, at the 3rd and 8th second of the simulation, were chosen to demonstrate the behavior of the rover at the given moments. The simulation shows that the model responds correctly to height changes. The wheels change their position according to the set signal, while the position of the chassis changes with the arrival of each next pair of wheels on the obstacle. When the third pair of wheels reach the set position, The whole body stabilizes at a height higher by 10 centimeters than at the beginning of the simulation. Then the rover descends from the obstacle, and the wheels with the body return to the initial state. Here is an example of another simulation. The excitation signal applied to the platforms on the left is in the form of a sinusoid with an amplitude of 10 centimeters and a frequency of 2 radians per second. The right side also receives the signal in the form of a sinusoid but shifted in phase by 180 degrees. The forcing signals simulate the rover's ride over uneven, bumpy terrain where the left side of the rover moves on a different type of terrain than its right side. The designed and built model of the rover allows checking the behavior of the actual design in a significant way. The model reflects the vehicle's major components, along with their moments of inertia and their mass. Both the rocker bogie suspension and the differential mechanism work correctly, as assumed. Conducted simulations prove that it is possible to run tests on the model to check how the rover will behave in various situations, even those with a risk of damaging the actual structure. Simulations performed, with the model allowed to test this system in extreme conditions. This allows defining the limits of each design. As a result, it serves to improve and enhance it. Conducted simulation of the rover behavior on large bumps shows that the structure also has limitations. When the obstacle is too high, there is a risk that the attempt to overcome it will end in the loss of the stability of the rover. It is a simulation when one of the sides could overcome the obstacle with a height of 52 centimeters, which is definitely too high. When the first and the second wheel from the left side are on the obstacle, and the third wheel starts to run over it, the mass of the whole vehicle makes the rover unable to maintain a stable position. The wheels detach from the platform subjected to force, and the rover starts to turn over. It is necessary to improve the performance of the design in this situation, which will be continued in further operations within this project. Thank you for your attention.